Let's suppose that we have 6 horses that are entered in a race. Assuming no ties, how many possible ways can they finish first, second, and third? So what we're going to do is we're going to set up 3 slots, first, second, third. How many horses are possible for the first place horse? There's 6 horses in the race, so there are 6 possibilities. Now, how many horses have the possibility of finishing second? Well, this time there are only 5, because whichever horse finished first cannot also finish second. So there's only 5 possibilities. What about third place? Well, the first and second place finishers are not an option. They cannot finish third because they've already been placed. So instead of 6, we have 4 possibilities. From the multiplication principle, we multiply all these together. That's 30 times 4, so 120. We call this a permutation. Let's do another example. Let's suppose that we have an Olympic event with 10 competitors. And how many ways can the gold, silver, and bronze medals be awarded? So again, we're going to have 3 slots: gold, silver, bronze. There are 10 competitors, so there are 10 possibilities for the gold medal. For the silver medal, we only have 9 because the gold medal winner cannot also receive the silver. For the bronze, both of these 2 are eliminated, so we have 10 minus 2, so 8 possibilities. The person who finished gold and silver cannot also get the bronze. So we have 10 times 9 times 8, that's 10 times 72, or 720 possible ways that the medals can be awarded. Here, we call this a permutation. The number of permutations of n objects taken r at a time without repetition. So what that means is we're going to take r of our n objects, and then we're going to put those r in an order. Permutations means changings of order. Okay, and so the formula for it is n factorial over n minus r factorial. So in this particular example, we have how many objects altogether? N. 10 competitors. So here n is equal to 10. How many are we choosing? Here the r is 3. This is the number of objects that we are choosing to lay aside in a group. Here we're choosing 3 of the 10 to lay aside and receive the gold, silver, and bronze medals. So what we end up with is permutation 10, 3. This is going to be equal to 10 factorial over 10 minus 3 factorial. 10 factorial over 7 factorial. Now, if you remember from when we did factorials, we can reduce this factorial. This is going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this last part we can write as 7 factorial. Then we've also got a 7 factorial in the denominator. And so this is equal to just 10 times 9 times 8, which is 720. So we can call this permutation 10, 3. I should point out that there are a couple that if we pull n of them aside out of the n, this should be an equal sign right here. N factorial, n minus n factorial. Remember that 0 factorial was defined to be 1. Okay. Here, in case you can't read this, this is permutation n comma r. There's several alternative notations for permutations. Here they are. You'll sometimes see permutation n comma r. You'll see the n coming first. Sometimes you'll see it written as a function with the n r listed in ordered pair. And once in a while you'll see the n written as a superscript. All variations on the same idea. Let's calculate a few of these to make sure that you can do it. We're going to calculate them by hand, but you should also punch them into your scientific or graphing calculator to make sure that you understand how to use your calculator's permutation function, because for the large numbers that'll be much more convenient than working out the factorials by hand or by just using a 4-function calculator. So here we've got 5 factorial divided by 5 minus 2 factorial. This would be 5 factorial over 3 factorial. 5, 4, 3 factorial divided by 3 factorial, which gives you 20. 7 factorial. Here you've got 7 factorial divided by 7 minus 7 factorial, which is 0 factorial. So this will be 7, 6, 5, 4, 3, 2, 1, which we'd usually just write as 7 factorial, and you'll end up with 5,040. So it's helpful to notice that 7, when we do the permutation, we just think of pulling a side out of those 7. You're going to have 7 blanks. 7, 6, 5, 4, 3, 2, 1. Multiply all those together. Permutation 4, 3. 4 factorial over 4 minus 3 factorial. 4 factorial over 1 factorial, which is 4, 3, 2, 1. So 24 possibilities. Okay, that's just a little bit of practice with using our formula for permutations.